we marvel at the vastness of space, a canvas for human ambition and scientific exploration. Yet hidden amidst the stars lies a growing problem, a consequence of our own making space debris. This invisible threat, a byproduct of our quest to reach for the stars, now endangers the very future of space exploration. Space debris, simply put, is any human-made object orbiting Earth that no longer serves a useful purpose. This includes defunct satellites, spent rocket stages, fragments from explosions, and even paint chips. These objects, though seemingly insignificant, pose a significant threat to active satellites, space missions, and even the International Space Station. Imagine a bustling city street littered with abandoned cars, discarded appliances, and construction debris. A chaotic scene where navigating becomes a challenge. Now translate that image to space, where the stakes are much higher. That's the state of near-Earth space, a region known as low Earth orbit, which is cluttered with thousands of pieces of debris. This debris ranges in size from tiny paint flecks to large defunct satellites, all of which can cause catastrophic damage if they collide with operational spacecraft. Unlike the debris on Earth, space debris moves at incredibly high speeds, often exceeding 17,500 miles per hour. At these velocities, even a small paint chip can puncture a spacecraft, causing significant damage. The high-speed nature of space debris makes it a formidable challenge to track and avoid. When two pieces of space debris collide, they can create even more debris, a phenomenon known as the Kessler Syndrome. This cascading effect can lead to an exponential increase in the amount of debris, making space operations increasingly hazardous. To address this growing problem, scientists and engineers are developing various mitigation strategies. These include designing satellites to deorbit after their mission ends, using nets or harpoons to capture debris, and even deploying lasers to nudge debris out of harm's way. International collaboration is also crucial. Space agencies around the world are working together to establish guidelines and best practices for debris management. By sharing data and resources, they aim to minimize the risks posed by space debris and ensure the long-term sustainability of space activities. The goal is to create a cleaner, safer space environment where future generations can continue to explore and utilize space without the looming threat of debris. It's a challenging task, but with continued innovation and cooperation, it's a goal within reach. Understanding and addressing space debris is essential for the future of space exploration. By taking proactive measures today, we can protect our space assets and ensure that space remains a viable frontier for discovery and innovation. The situation is more alarming than we might imagine. Over 27,000 pieces of debris larger than a softball are tracked by global space surveillance networks. These objects, traveling at speeds up to 17,500 miles per hour, can cause significant damage upon impact with operational satellites or spacecraft. The danger posed by space debris is not theoretical. In 2021, the International Space Station was forced to maneuver to avoid a potential collision with debris from a destroyed Chinese satellite. Such near misses are becoming increasingly common, highlighting the ever-present danger. The Kessler Syndrome, a domino effect in space. In 1978, NASA scientist Donald J. Kessler proposed a terrifying scenario known as the Kessler Syndrome. This concept has since become a critical consideration in the field of space exploration and satellite deployment. Kessler's theory suggests that as the density of space debris increases, so too does the probability of collisions. Imagine a crowded highway where each car crash leads to more debris on the road, causing even more accidents. In space, this means that every piece of debris, no matter how small, has the potential to cause significant damage. Each collision, in turn, creates more debris, leading to a runaway chain reaction that could render near-Earth space unusable for generations. This cascading effect is what makes the Kessler Syndrome so alarming. If left unchecked, it could severely impact our ability to use satellites for communication, weather forecasting, and even GPS navigation. The implications of the Kessler Syndrome extend far beyond just the immediate aftermath of a collision. Satellites are crucial for modern life, providing services that we often take for granted. From the moment we wake up and check the weather, to navigating through traffic and even watching television, satellites play an integral role. The International Space Station, for example, relies on a clear path through space to safely orbit the Earth. Increased space debris could pose a significant threat to the safety of astronauts and the functionality of the station. The potential for a catastrophic event increases with each new piece of debris. To combat this growing issue, space agencies around the world are developing strategies to mitigate space debris. These include designing satellites to deorbit after their mission is complete, using nets or harpoons to capture debris, and even deploying robotic arms to remove larger pieces. International collaboration is essential to address this global challenge effectively. As we look to the future and plan missions to Mars and beyond, understanding and mitigating the Kessler Syndrome becomes even more critical. Ensuring the sustainability of space activities is not just about preserving our current capabilities, but also about enabling future generations to explore and utilize space. The Kessler Syndrome serves as a stark reminder of the delicate balance we must maintain in space. It underscores the importance of responsible space exploration and the need for innovative solutions to keep our orbital environment safe and sustainable for years to come. The high cost of space debris. The consequences of space debris extend far beyond the theoretical. Collisions with debris can destroy vital satellites, disrupting communication networks, GPS systems, and weather forecasting. The economic impact of such an event could be catastrophic, affecting global commerce, transportation, and even national security worldwide. Global efforts for a cleaner space. Fortunately, the international community recognizes the threat posed by space debris and is taking steps to address it. Organizations like the United Nations and the Interagency Space Debris Coordination Committee are working to establish guidelines for responsible space operations and develop technologies for debris mitigation. Our responsibility to future generations. The future of space exploration, and indeed our continued access to space-based technologies, depends on our willingness to address the growing problem of space debris. As we continue to launch more satellites and spacecraft, the amount of debris in orbit increases, posing significant risks to both manned and unmanned missions. This debris, ranging from defunct satellites to tiny fragments from collisions, travels at incredibly high speeds, making even the smallest piece potentially catastrophic. Proactive measures, such as designing satellites for easier disposal, are essential. Engineers and scientists are working tirelessly to create satellites that can deorbit themselves at the end of their operational life, reducing the amount of space junk. This involves innovative designs that allow satellites to burn up upon re-entry into Earth's atmosphere, ensuring they do not contribute to the growing debris problem. Additionally, developing technologies for debris removal is crucial. Various methods are being explored, including robotic arms that can capture and remove debris, nets and harpoons to snag larger pieces, and even lasers to nudge smaller fragments out of orbit. These technologies are still in the experimental stages, but they hold great promise for cleaning up our orbital environment. It is our shared responsibility to ensure that the final frontier remains a realm of wonder and discovery, not a hazardous junkyard of our own creation. The beauty and mystery of space have inspired generations of scientists, explorers, and dreamers. We must act now to protect this legacy, ensuring that future generations can continue to explore and learn from the cosmos without the threat of space debris. By taking action today, we can preserve the future of space exploration for generations to come. This means not only developing new technologies and strategies for debris removal, but also fostering a culture of responsibility and sustainability in space activities. Educating the next generation of scientists and engineers about the importance of space debris management is vital. Encouraging international cooperation and establishing clear guidelines and regulations for space activities will also play a key role in addressing this global challenge. Together, we can ensure that space remains a place of endless possibilities and discoveries, a testament to human ingenuity and our enduring quest for knowledge.